So type 3 equations are simultaneous equation type. That is, instead of giving you one equation, you'll be given two simultaneous equations. For example, so if sine theta has to be equal to half and cos theta has to be equal to minus root 3 by 2. So I want those values of theta for which sine theta will be equal to half and cos theta will be equal to minus root 3 by 2. So what is the general solution for this simultaneous set of equations? So what we analyze for this question is, okay, sine theta is equal to half. So what is the quadrant diagram for sine theta? Plus, plus, minus, minus. So sine theta will be positive in the first two quadrants, negative in the next two quadrants. So correspond to sine theta is equal to 1 by 2. Theta has to be equal to 30 degrees, right? Theta is 30 degrees in the first quadrant and its allied position in the second quadrant is 150 degrees. So at these two positions, sine theta will be equal to half. Now if you draw the diagram for cos theta, quadrant diagram for cos theta. For cos theta, it is plus, plus, minus, minus. That's the quadrant diagram for cos theta. Now cos theta has to be minus root 3 by 2. So root 3 by 2 corresponds to 30 degrees for cos. Cos that is root 3 by 2. But I want minus root 3 by 2. So I cannot go to first and fourth quadrants. Because in the first and fourth quadrants, it is 30 and minus 30. The value of cos theta is positive. I want my value of cos theta to be negative. So I need to go to the next two quadrants, right? So this angle is 150 degrees, this angle is minus 150 degrees. These are allied positions to theta is equal to 30 degrees. Now sine theta will be equal to half at these two positions of the rays. Cos theta will be equal to minus root 3 by 2 at these two positions. So if these two simultaneously should happen, this also has to happen, this also has to happen. Obviously the ray has to stop at this position because these two are same. So the answer is something like you have only one position per revolution which satisfies both these equations simultaneously, and that this position for these values is 150 degrees, that is 5 pi by 6. So half can be written as sine of 5 pi by 6 minus root 3 by 2 can be written as cos of 5 pi by 6. So for simultaneous equation type, you need to first search for some solution which works for both the equations, and then we know that you're getting only one solution per revolution. So next revolution, so next time you get the same position when theta is equal to 2 pi plus 5 pi by 6. Next time 4 pi plus 5 pi by 6. So 5 pi by 6 is an answer. Next revolution 2 pi plus 5 pi by 6. Next revolution 4 pi plus 5 pi by 6. So what is the general solution for this? 2n pi plus r minus, sorry, you don't have a minus, 2n pi plus 5 pi by 6. So the solution for simultaneous equations look like this. So you have only one solution for revolution. So the answer for this is 2n pi plus 5 pi by 6. So now let us look at the general solution for simultaneous equations. So how we write in a formula form. So in type 3 questions, you'll have questions like this. Sin theta is equal to sin alpha and cos theta is equal to cos alpha. You'll be given two equations. So what is the solution for this? Theta is equal to 2n pi plus alpha. So this is the general solution to this set of equations. So now you need to see this carefully. Sin theta is equal to sin alpha and cos theta is equal to cos same alpha. So that means for the same value of alpha, these two equations have to be valid. We need to search for that value. For example, so if you have sin theta is equal to half and cos theta is equal to 1 by root 2, so you cannot have solution for this, because when sin theta is equal to half, cos theta has to be equal to either plus root 3 by 2 or minus root 3 by 2. For only those values of cos theta, we can find the solution for theta. So if you are given these two simultaneous solutions, the answer is no solution, because when sin theta is equal to half, cos theta cannot be equal to 1 by root 2. So this solution has to be used if the values of given trigonometric ratios are nicely working out. And you can have any two equations, any two simultaneous equations, for example sine equation and a tan equation also. For all those simultaneous equations, the solution is 2n pi plus alpha. I hope you have understood the logic also. So now, before going forward, let us summarize all the three types. So in this video, let us summarize what we have learned in trigonometric equations till now. So we have seen what trigonometric equation is, what the meaning of general solution versus principal solution is. So I hope you have remembered these two topics. These are important. What is general solution and what is principal solution. And next we have seen simple equations of three types. So for type 1, you have three different types of solutions. For sine, correspond to sine and cosecant, correspond to equations involving sine and cosecant. The solution is theta is equal to n pi plus minus 1 whole power n times alpha. Corresponding to the equations involving cos and secant, theta is equal to 2n pi plus or minus alpha. And corresponding to tan and cot, theta is equal to n pi plus alpha. And for these equations, usually we have two solutions per revolution. These equations, you have two solutions per revolution. Next, if you go to type 2, these type involving squares of trigonometric equations. So whenever you have squares, so whatever may be the trigonometric ratio you are dealing with, the answer is always n pi plus minus alpha. If you have sine square theta is equal to sine square alpha or any trigonometric ratio, theta is equal to n pi plus or minus alpha. Now if you go to type 3 is the simultaneous equation type. So if you have two equations of the form sine theta is equal to sine alpha and cos theta is equal to cos alpha, theta is equal to 2n pi plus alpha. So these are the standard results which you need to remember if you want to go forward in this topic. So now once you have made sure that you have remembered all this, now let us go to our problem section.